So in this video, we're going to be talking about the product rule. And what the product rule is it's another differentiation technique, just like the power rule. So it's kind of a formula that tells us how to take the derivative of something. And what that something is it tells us how to take the derivative when we have two functions being multiplied by each other. So when we have two functions being multiplied by each other, we can't just use power rule on it. There's also another kind of formula that we have to apply. So that's what this formula in the top right here is saying. H of x is defined as two functions being multiplied by each other. So we have f of x and g of x being multiplied by each other. We don't know what they are right now, but they're just two functions that are being multiplied. That's the key. And so if we have two functions that are being multiplied, and then we want to find the derivative of that whole thing, we want to find the derivative of h of x, this is how we have to do it. This says keep the second one the same, and then multiply it by the derivative of the first, and then add the first function the same, multiplied by the derivative of the second function. So this is the pattern or formula that you're going to use to do derivatives when you have two functions multiplied by each other. And it looks a little bit confusing in this kind of abstract general form, but once you see a few examples, hopefully that will help. So let's say that we have some function y, and that function is equal to x squared times the whole quantity 4x squared plus 3. And we want to find y prime. So we want to take the derivative of this. And what you'll notice is that we kind of have two pieces here. And by piece, I mean this first term that's in parentheses, and then the second term that's in parentheses. And what I've done is I've written them in different colors because the product rule is what we use when we have two functions being multiplied by each other. And you can see that x squared is its own function. We could graph that. That would be just a standard parabola. And then 4x squared plus 3 is also its own function. We could graph that, and that would be a parabola that's been dilated by 4 and shifted up 3. So each of these kind of units are their own functions, and they're being multiplied by each other. So that's how we know that we need to be using product rule, is we have two functions being multiplied by each other. So what we're going to do is just use the same formula over here. And so what this formula says is that we're going to start by taking the second function and just keeping it the same. So we're just going to rewrite the second function. And so the second function here is this 4x squared plus 3. So what we're going to do is we're just going to rewrite that. And then we're going to multiply this by f prime of x. So that means the derivative of the first one. So what is the derivative of this first one? X squared, well, if we use power rule on this, we know the derivative of x squared should be 2x. So we're going to take what we have here and multiply it by 2x, because that's the derivative of the first one. And now this formula says we need to add, and then we're going to rewrite the first function the same. We're not going to do anything to it. And the first function was x squared. So we're just going to rewrite x squared the same. And now this formula says we need to multiply this x squared by the derivative of the second function. And so our second function is this 4x squared plus 3. And so we need to take the derivative of this. And the derivative of just a number or just a constant is going to be 0. So the derivative of 3 is 0. And then the derivative of 4x squared, we can use power rule on that. So we'll multiply the 2 by the 4 out front, and that will be 8x. So the derivative of the second function here is going to be 8x. And so this right here, this whole thing, 4x squared plus 3 times 2x plus x squared times 8x, this whole thing is the derivative of y. And so we got it by just applying this formula right here, the product rule formula. So hopefully you can see that it's kind of a piece-by-piece process where you take the second one, keep it the same, then multiply it by the derivative of the first, and then plus this first one the same multiplied by the derivative of the second. And you might be wondering if you can flip this formula, if you could do this part here, f of x times g prime of x first, and then add g of x times f prime of x. And yeah, that's totally fine, right? Because order of addition doesn't matter. So I could have written this piece first and then done plus this piece, and it wouldn't matter. So you can flip that order if you want, as long as you follow this same general pattern. So here's another example where we have a function y, and y is defined as the product of two other functions. You can see that we have this 9x squared plus 4x piece, and then we have this x cubed minus 5x squared piece. So again, we can recognize that we're going to be using product rule here because we have two separate functions that are being multiplied by each other. That is the key. They're being multiplied by each other. So we want to find y prime. We want to find the derivative of this. So that means we want to look over here and use this formula again. So the product rule tells us that if we want to take the derivative, we're going to rewrite the second function and just keep the second function the same. So our second function here is this one in green, x cubed minus 5x squared. So we're going to take that and we're just going to rewrite it. So that second piece is going to stay the same. And then product rule tells us that we need to multiply this by the derivative of the first one. So the first function is this 9x squared plus 4x, and we want to take the derivative of it. So we can first look at this 9x squared piece. If we apply power rule to this, we're going to multiply the 2 by the 9, and we're going to get 18x. So the derivative of the 9x squared is 18x, and then we're going to add the derivative of this 4x piece. And if you were to use a power rule on this, you would see that the derivative of 4x is 4. So that is the derivative of the first piece, 18x plus 4. And so now we need to add the first function just written the same. So now we're going to take the first function and just rewrite it. Now I'm going to go on to the next line here. So we're going to take that first function, 9x squared plus 4x, and that piece is going to stay the same. And now we need to multiply that by the derivative of the second piece. So the second piece is this x cubed minus 5x squared. So we need to multiply by the derivative of this. X cubed, the derivative, if you use power rule on that, is going to be 3x squared. And then we need to subtract the derivative of 5x squared. And the derivative of 5x squared, again, if you use power rule, is going to be 10x. So this whole thing here, this x cubed minus 5x squared times 18x plus 4 plus 9x squared plus 4x times 3x squared minus 10x, that whole thing is the derivative of y. And so we got that by using the product rule, and we knew we had to use the product rule because our function y is a composition of two functions. It's two functions being multiplied by each other. So that's how we knew that we were going to use product rule. So this is the last example that we're going to look at. We have y, which is equal to the square root of x times x to the 5th minus 11x to the 8th. And so we're going to be using product rule here, and we know that because we have two functions, two pieces being multiplied by each other. The first piece is the square root of x, and then the second piece is the x to the 5th minus 11x to the 8th. And so we're going to use the product rule to find the derivative of this. Now hopefully you notice something is that we have a square root of x here. And in the previous power rule video, I said that whenever you're dealing with derivatives and you have any sort of roots involved, always rewrite that root using an exponent because it'll make you taking the derivative of it far easier. So what I've done here is I've rewritten, we used to have the square root of x here, and I've rewritten it as x to the 1/2, because whenever you're dealing with derivatives and you have roots involved, it's always going to be helpful to rewrite it like that. Okay, so now let's find y prime. So if we look at our formula over here, it says that we're going to just rewrite the second function first. So our second function is this green one, and we're just going to rewrite that and keep it the same. So that's going to be x to the 5th minus 11 x to the 8th, and then we're going to multiply that by the derivative of the first function. And the first function is this one in red right here. So we need to multiply by the derivative of that. So if we use power rule here, we're going to multiply, bring that 1/2 down. So we're going to have 1/2 x, and then we're going to subtract 1 from the exponent. So 1/2 minus 1 is going to be negative 1/2. So that is the derivative of the first piece. And then we have to add the first function now written normal. So we're going to take that first function, x to the 1/2, and that's going to be written normal. And then we need to multiply that by the derivative of the second one. So if we look at the second one, we want to take the derivative of that. The derivative of x to the 5th is going to be 5x to the 4th. And then the derivative of 11x to the 8th, that is going to be 11 times 8, that is going to be 88. and then subtract 1 from the exponent. 8 minus 1 is going to be 7. So the derivative of that second piece, that green piece, is 5x to the 4th minus 88x to the 7th. And so this entire thing right here, that whole thing, is y prime. That is the derivative of y. So it does get a bit messier, a bit long when using product rule, but it really is helpful to kind of first identify what's my first function, what's my second function, split it up into your first and second piece, and then just go and do each piece like this. So hopefully that was a nice intro into the product rule and a few different examples of how to use it. If there are any kinds of problems that you come across where product rule is involved and you want to see more worked solutions of that, please let me know in the comments, and don't forget to subscribe.